Welcome, everybody, to the American Space Museum. I'm Mark Marquette. We're so glad you're with us to stay curious today, Monday, October 21st, 2024. And we're going to talk about comets. If you've not been living under a rock, you've heard there was a comet in the night sky after sunset. I'll bet 90% of you did not see it, but I'll bet 90% of you saw pictures on Facebook. And my way of saying, hey, Marty Winkle, my co-producer on our Streamlabs program there. Marty, you saw it, I'll bet, and on Facebook, see pictures of Comet Tashinshan.
Well, I'm not on Facebook, and you probably shouldn't ask me if I've seen it or not.
All right, because you didn't see it.
No.
There's a comet above my head. A comet. This is not the comet that we saw. Every comet's billed as Comet of the Century. There's hooray for Comet Hayutake, one of my favorite ones. That's from 1996. All right. The year my daughter was born. If Jesse's watching, she's the Hayakutake comet. Revealing the anatomy of comets, astronomy. Two of the here's the other one. Oh, I didn't bring a sky telescope with me, doggone it. But astronomy magazine, Comet, how to see it, the Great Comet Crash. That's when, in 1994, when a comet smashed into Jupiter. Comets are a big part of our solar system, and I'm going to explain a little bit why. And however, the comet that I was going to make for you today, on a shtick that I've done for like 30 years, none of this, there's no dry ice to be found in anywhere around here. Apparently, the supply chain of dry ice is broken down at Publix and other sources of mine. And then I've misplaced my comet kit, so to speak. In fact, I do know where it's at. I left it home in the garage because I made a comet for our new bilingual STEAM teacher, Natalia Sepulveda. Natalia's going to be here November 2nd to do a program. So I couldn't do all that I wanted to do, and we've had quite a day here today, Marty. And we had an important meeting with our chairman of the board, Larry Osterly. And I'm going to read you this announcement that we're going to put out tomorrow. The American Space Museum in Titusville, Florida has announced a restructuring of its executive officers and appointed new members to the nonprofit organization's board of directors effective immediately. Gabriel Rothblatt has been named the executive director, overseeing financial development and grant processing, and Mark Marquette, myself, has been named museum director, in charge of the day-to-day operations and outreach. The changes in leadership was necessitated by the unexpected death of ASM Executive Director and 20-year employee Karen Conklin, who lost her battle with cancer last August. This is from our board chairman, Larry Osterly. Quote, the museum is still recovering from the sudden loss of Karen, unquote. These leadership changes will position us for the future and ensure the museum's long-term success, unquote. We also added three new board members. They include Emily Carney, creator of the influential Space Hipsters Facebook. She also works for Space 3.0. Marty Winkle, my co-producer for 4.5 years, retired former NASA contractor for 40 years. And Stephanie Robinson, who's the project coordinator for Career Source Brevard. She is a very been active in career placement and that sort of thing. Rothblatt has been a space advocate for more than 2 decades and is president of the Florida Space Development Council, the National Space Society's Brevard County chapter. He works for MIO LLC as a property manager and has previously managed a restaurant franchise and worked as an insurance broker. Rothblatt is the executive chairman of the National Space Society's International Space Development Conference to be conducted May 2025 in Orlando. As for myself, y'all know me pretty well. I'm a former Associated Press photojournalist and business sales manager. I've been involved with the museum as community liaison for 7 years, became the face of the museum. And Marty and I produced this Stay Curious podcast since March 23rd, 2020. now 4.5 years later. I got on the board. 1152 is our episode today. And I'm involved in several boards on the Titusville and Cocoa Beach Chambers and the Museum of Brevard. And I'm also on the National Space Club board of directors there. So Larry Ostrey, our chairman, says this in our press release, quote, "I am excited about the new leadership and the future of the American Space Museum. Our mission is to continue to preserve our spacefaring history and provide outreach for the Space Coast. Please stay tuned for our upcoming events." And we have about 8 other board members. They include Troy Post, who's involved with the North Brevard Economic Development Commission. Bonnie King is our treasurer. She was the deputy director of the Space Coast Office of Tourism for many years. Steve Lloyd is a senior vice president at a company that builds a lot of buildings around here, whether they're space or not, BRHP. Bob Seek, who launched 51 shuttle launch space shuttle, I think 57 is how many Bob launched. He is our executive member at large. Chuck Jeffrey, of course, is our Bid Again Auctions supporters. Dr. Stephanie Sherby, she is a vice president general manager at All Points Logistics, a great supporter of our museum. And we've got Josh, where's Josh's name there? And David Mandernick on there. So anyway, a great board. The board has actually segued from the Apollo era space workers to the shuttle era space workers here since I've been here. And I'm humbled and honored to lead our museum on our day-to-day operations. Gabriel and I have known each other since we organized the 321 Day in March, celebrating Ozzy Osbourne's death and the area code 321 on March 21st. And so it's a good fit, and I'm very happy with what we're doing here, and happy that Marty's on the board. And we are Marty's one, as well as many of us on the staff that and the board acknowledges had not been that active the last few years. And so we're getting active with stuff on there. So Marty, thank you for your support. Marty's been a financial money generator for the museum for 20 years. And we were founded over 25 years ago as the U.S. Space Walk of Fame Foundation, and built the beautiful Space View Park that many of you have seen, where over 30 handprints of astronauts are in bronze at the Mercury, Gemini, Apollo, and Shuttle monument areas. And I couldn't be happier to have the team that we have here. We've all known each other since, some of us 7 years since I came on board. Nick Enix, our collection manager and curator, is a very important cog in our volunteer wheel. Thank you, Nick, for all that you do. And one area we're going to attack first is giving Nick a budget so we can change out some of the look of our galleries here. So Emily Carney's a great influence. Of course, she's Space Hipster #1, and I'll bet all of you are part of the 65,000 that follow Space Hipsters Facebook group. And we're excited about her, and hopefully she'll be doing some podcasts here in my place. We've welcomed her to come on anytime. So anyone, I don't have my laptop in front of me here, Marty, so if we've got anything there that needs attention, please let me know. Other than that, I'm going to segue into our Marty's question. How you doing, Marty?
I'm doing good. Mark, we got to put it up on a video so I can see it.
There we go.
Okay. Kathy Thornton tested the DACT during long-duration, high-altitude flights. What is the DACT?
DACT. What is that all about? Kathy Thornton, a spacewalking astronaut. She was also on 49, didn't spacewalk. Long-duration, high-altitude flights. So put your thinking cap on, and at the end of this little lesson on what are comets, why are they important, we'll give you the answer to Marty's trivia question of the day. That's a good one, buddy. Well, this comet called Tashension, and then it had some numbers behind it. Those numbers are an automatic group of telescopes that survey the sky every night, trying to catch the first glimpse of incoming comets coming into the sun. Now, what do we mean by incoming comets? Comets are generated 10 times further, maybe 100 times further away than Pluto. That's right. Maybe up to 40 to 400 billion miles away is a reservoir called the Oort cloud, OORT. I'm going to show you a crude rendition of this. Once again, I couldn't do the program I wanted to today because of our long staff meeting, and then I didn't have it all together where I thought I had it. And so we'll just fly with it. But obviously, the best photograph says Carlton Bailey of the comet as Godzilla is there, taken by an astrophotographer in one of the islands of the South Pacific, by the way. Now, number one, I could barely see this naked eye. All right. I'll show you my street view of it. I had to see where it was by a photograph first to see it. All right. Number two, it never got as bright as any of the stars of the Big Dipper or the Cassiopeia, the W that's on its side in the northeast when the sun sets. That's second magnitude. When you look to the west, you saw a bright star. That was Venus and still is Venus. Venus is -2 magnitude, and the difference between one magnitude and the next, from first magnitude to second, is a logarithmic scale of 2.5. So second magnitude is 2.5 times fainter than first, and third magnitude is 2.5 times fainter than second, and then go 2.5 times again, and that would be how many times it is fainter than first. So it wasn't easy to see naked eye. Only you out in dark skies, the privilege to live away from light pollution, saw it very well. Number two, it came in from the outer solar system for its visit, and its orbit maybe takes 80,000 years. So you're never going to see it again. All right. And in 80,000 years, it's headed back out now. All right. To the Oort cloud, or at the outer areas of our solar system. Now, this OORT cloud is like a torus, like a donut around us. Or it could be maybe it comes from all directions. It's just not like in the plane of where all the planets orbit, because this comet came way above where the plane of the orbits, where the plane of most of our planets orbit. What I mean plane is I mean a plate. Don't have a plate in front of me, but I'll use this Ad Astra magazine. And this plane is the plane here, all right, of our solar system. The sun's in the middle, and most everything is in like a few narrow degree band up or above this narrow band, all right. These comets are coming in from way up here, then coming down. And that's what the problem with Pluto is it's in an orbit like that, like a comet. So, this is what a comet looks like up close. Oh, no, I want to go here. So the comet, when it come around the sun, in the morning sky, you heard them talking a lot about the morning, but the heat of the sun strips off material and basically melts a comet that is a snowdrift or a dirty snowball. It is very porous. It's very loose. It's rock. It is ice. It is all kinds of things that we're going to talk about briefly. So so it's made of things that life come from. Okay, it's got a lot of things in that the elements of life are all about, and a lot of water. So we think that comets seeded the water in the inner solar system. In our inner solar system, out to Neptune, is very small. That's just 2 billion miles, okay? And this Oort cloud is 100 billion miles away. So looking back at the very edge of our solar system, the planets occupy a little small space in the solar system. So this is important because these comets are light. They're affected by the gravity of Saturn, Jupiter, also Neptune and Uranus if they get close to them. And their tail grows longer as they get heated up closer to the sun. This one went behind the sun. Some crash into the sun. Over a dozen comets a year are swallowed up by the sun. All right, they don't get very bright. Why do they get long tails and get bright? We're not sure. We know the volatiles in them reflect the sunlight. There's no flame coming off of them. And this is where the comet went. Okay, over the next, here it is the 17th. We're up there October 22nd tomorrow. And it's getting fainter as it's going far away from the Earth and the sun. And an odd thing about the comet now is its tail is flowing ahead of the direction of travel. That's right. We think of a tail blowing behind you. Well, the sun is blowing it away from the sun, and it's headed out of the solar system. So it's actually heading into its own tail that can be millions of miles long, and yet all the material would, so to speak, fit in a suitcase. Here's a close-up of a comet that I can't pronounce the name of, but we investigated it. The Europeans did, and actually landed on it with this is only about a mile across, okay? Two lobes apparently almost crashed into each other like two dirty snowballs. Look at the stripping in the upper left-hand corner of those layers where you can see material, and in this picture above me is being stripped off of it as it got closer to the sun. This was taken further away from the sun as it started to heat up. Boy, did it react, and we followed it, landed on it. Humans did. It was a European Space Agency mission that we helped out with. So the nucleus, this is looking at the nucleus, the center of a comet, all right? This is unusual that it's two lobes, or is it? Is it two snowballs that actually came together gently and fused, or is that where material has been eroded for millions of years as it visited periodically inside the inner solar system? We don't know. Marty, you have a question there.
Yeah, I have a question. As the comet travels further from the sun, does that mean that there is no tail? If it gets so far away, let's say beyond Pluto, for example, is there no tail at that point?
Yes, the tail starts diminishing out by about Mars.
But does that mean there's no debris coming off the comet?
Correct. As this is a comet here, okay, and gosh, Genshin something, I forget the name of it, and that is the comet out by way out by Mars and Jupiter, Marty. So there's not enough heat energy or solar energy to strip off anything. Now there might be some invisible gases coming off of it there. And then over here's where it's closer to the sun, and the spacecraft had to get further away to be safer. But you're right, then it'll go back out. So it melts and then it's frozen. And then melts again and frozen over its trips around the solar system. Now the most famous comet is Halley's Comet. And we all know that Halley's Comet was in 1986 and coming back in 2062. How many times has Halley's Comet orbited the sun? We don't know, but it's about 10 miles in diameter, pretty big comet. So it'll take maybe thousands of visits. And yes, Marty, they've just eventually fizzled out to just an ember. All right, and we're not sure what happens to them. Like I said, some of them are sucked up by the sun. Some are smash into Jupiter, pulls in a lot of comets, and Saturn must too. Here is the plane I'm talking about. Looking at the orbits of Venus, Mercury, Earth, Mars over here above my head. The comet came in, went way out by Venus. It didn't get as close to the sun as Mercury, and then it went back out. How did that look from a perspective of the plane of the solar system? It came in from way up high and did a U-turn below the where Mercury, Earth, and Venus and Mercury orbit, and then went back out. So it's like I said, like it's coming in, instead of going around like this, it came in like this and back out. Yes, Marty, on that UCX family microphone.
Okay, so I have another question then. It slingshots around the sun. What does it slingshot around to come back? Is there another sun out there? Maybe it's slingshotting around?
Oh, that's a good question. Actually, it keeps slowing down. It does a U-turn. It does an absolute U-turn, and I've always wondered about that with Halley's Comet. Comes around every 76 years. It goes out a little bit past Neptune, and then at some point, the gravity of the sun pulls it back in. Its momentum is not enough to keep going out straight, and the laws of Newtonian physics take over and pull it back into, it does an actual U-turn. And that's another part of theoretical cometary physics, is at what point does it really stop, or does it sort of just like go around a corner like a race car would, and all of a sudden the sun is bringing it back in. But if it got enough energy, maybe coming close to Jupiter, yes, Jupiter could fling it out of the solar system, and probably has ones like that. Excellent question, Marty. Keep them coming.
Okay, this question comes from Steve Holcomb. So, the Oort cloud forms a more spherical shape around the sun. Yes? No?
Yes, Steve Jokums. The Oort cloud, we think, is a sphere, like we're inside a beach ball. And at the very edges of that beach ball, inside, if we were inside a beach ball, most of it's empty space. You got planets and asteroid belt and meteorites and meteor storms. Meteor storms, by the way, a lot of them, like the one that's going on now, the Geminids, follow the Orionids, are pieces of Halley's Comet in a debris path. It's in the we're going right now through the path of Halley's Comet, but Halley's Comet is way out past Neptune right now. It's just about to do that turn and come in. So we're inside a big beach ball, and that physical part of the ball that we're looking at is not very thin. It's very thin, but that's where all the comets are. By the way, Steve Jokins and I are wearing scarlet today. I didn't wear scarlet today. My hat's in the car. Should have brought it in, because Ferrari finished 1 and 2 at the Austin U.S. Grand Prix, and he's a big happy camper. I know he's flying the Marinella flag at his house today. So that was awesome, buddy. And it's great to share things like that about our lives with you space geeks out there. Steve Jokim's a great supporter up there at Lake County Spaceport. So good questions. I got a couple examples of that here. I didn't load up a whole bunch of images because I thought I was going to make a comet out of dry ice, and by golly, I will do it one day. But you're going to see the results of it as if I did. This is a picture taken last week by my friend, what is my friend's name? Johnny Horn. Johnny Horn up in North Carolina, Stedman, North Carolina. He worked for the Fayetteville Observer for a long, long time. The tail actually had an anti-tail in front of it, and a spike in front of it. And this is hard to explain, but this is actually, the tail has flipped over because it is now driving into its own. The bright part is the nucleus, and we don't see what that looks like, the rocky body, because it is now volatile, exploding. Imagine water boiling, stuff's coming off of it like crazy. Some of it is distinctively debris, and some of it's gas. And this comet didn't have a lot of gas on it, because gas follows a different solar path of the solar wind. But that's not a spike in front of it. It's actually the tail completely flipped around. So this is the bottom of the tail. It's like folding it over on itself. Now, this was from my home in Port St. John. Right there's the comet. All right. The tail is rather long. The only way I could direct other people to the comet was to kind of line it up to that pine tree, and then say, look at the top of the pine tree, and then just look to the left. Now, this is an airplane, lights going on. This is only a 4-second exposure, and all of the urban lights there is amazing that you could even see it this good. This is Comet Hale-Bopp. Certainly a lot of you heard about Hale-Bopp in 1997, and it was very noticeable with the naked eye. It looked like a little dust ball smudge up there with the tail. The blue part of it is the gas tail that is spewing off. And we're trying to understand why certain parts of comets, the solid debris, the ice, the rockiness, a sandy part of it, and so forth, is stripped off. The tail of this wasn't very long. But once again, if this is what you're looking at, here is a tail. Let me find something better. Let me just, I think I can use this as a demonstration. Marty, would you hand me that microphone there in the bottom there, that handheld mic? I want to make all right. So you're assuming the comet is looking like this, complete profile of it. How do you know it's not like this? All right. That's why it would look shorter. Or if it's coming straight at you, the tail. So maybe we're looking at it like this, or the tail is real long like that. So it's tilted at us a little bit. It's coming out away from the sun again. The and Actually, this is when it was before it was going around the sun. Spectacular in the night. It was way up there too. It was visible at 10, 11 o'clock at night. Hale Bopp, and a lot of history about that in pop culture and so forth. But obviously, the coma, the front is very, very volatile. The sun's rays, sun energy, all this unseen energy from the sun is stripping off the gases in another direction. Here's another typical comet, Comet C-22, discovered by the ZTF Observatory System type of thing. This was 2023. This is how we see a dozen to 24 comets every year. From your backyard, there's amateur astronomers that are obsessed with this. They took a time exposure of probably 10 minutes. You can tell that because the stars are trailed 10 minutes to get that ball of icy debris. And let's see here. Where am I going with this now? Our backdrop here is a beautiful comet Leonard. This was photographed in the southern hemisphere. This looks a lot like Hyakutake did back in 96. The tail again is really long and not as prominent. So comets are a lot like cats, we say. You can't predict them. You don't know where their tail is going to swing left or right, how long it's going to be. And that's why they're fascinating and one of the most important misunderstood objects in the solar system. Now, this is Comet Neowise with my friend Derek Demeter at the college in Sanford, Florida. There, that's what is that, Marty? Seminole State University over in Sanford. Thank you, Marty. This was a more spectacular comet than the one that we just had media about. You could see it with the naked eye. It was particularly, I remember photographing it up at the harbor here in Titusville. But again, it was in the twilight. And by the time it had gotten in the dark part of the sky, it had passed the Earth. Yes, Marty.
Okay, my question number 3. And I won't say it's a dumb question, but it's probably not a smart question. But Mark, why is the front of the comet, white? Is it reflection from the sun, or is it that hot from the sun?
Great question, Marty. That is a great question. It is not hot. It is cold. It is white because it is like it's all reflected sunlight. This is all reflected sunlight. There's no energy source coming off of here that is making its own light. So it's all reflected sunlight. That's why it's getting less bright as it's moving further away from the sun. And it looks white because the volatiles are white like snow. It is mostly water. All right. And but as you saw in Comet Hale Bopp, it had you got this it's white and kind of brownish in there, so that's a lot of debris in there. It's a dirty comet. All right. And then the blue is gas coming off of it. Now this comet has greenish glow to it. Some have got different colors to them, to the spectrum, and that gives us a clue to it's heavier in other elements than another one. Like this one's heavier in ammonia, maybe because it's greenish. Here is, I think that's just the comet. No, that's Neowise again. Neowise over Stonehenge, all right? And this was a pretty noticeable comet, naked eye. That was, I think it's 3 years ago. Yeah, probably 3 years ago. Now, Photographers had a great time with Comet Tashinshin. It was a very photographic comet, as you've seen the pictures. And this, again, this did not look like this. This is multiple images the way photographers do, or a 10-second exposure at high ISO, that type of thing. As it's there, you got the belt of Venus going across here, the pinkish rim there, the Earth's at sunset. And here's another final picture, a couple final pictures of some interesting comets. As we watch comets, this comet was not visible to the naked eye, all right, wasn't visible like this one, completely visible to amateur astronomers and telescopes or professionals. And here you actually see the comet tail breaking away, Marty. This happens to other comets where, like, the tail all of a sudden detaches. Some of these tail, I think this one completely detached. And so that tail debris that's being reflected, all that debris is now dispersing into space because it's lost this momentum, because it's lost the head of the tail. And they're going, I could stand corrected, but I think they're going in the order pretty fast, 5 to 10,000 miles an hour. When they're getting caught in the looping around the sun, and then they slow down appreciably to where they reach a speed where the solar gravity pulls it in. All right, the solar gravity is holding everything in place, including the Oort clouds. So you see them detach, then the diffuseness comes, and then the Earth piles through this diffused area, and there, bingo, we have meteor showers. And this is a woodcut or rendering of a comet in the 1800s that had 1, 2, 3, 4, 5, 6 tails. Now, this was before photography, but many people recorded that this comet had different tails up there. That was one comet. So we don't know much about this. It might be embellished a whole lot by the picture here, but pieces of it must have disintegrated, and all the pieces had different tails coming off of it. It's the only explanation. Then we had a comet not too long ago that they called the Devil Comet because its coma, the center of it, looked like devil horns. Astronomers give nicknames to all kinds of stuff in there. But this is a very unusual comet. Its tail did not get very big because it did not get close to the sun. All right, it maybe only got as close as Venus, yet it was enough to warm up this snowball of maybe a half a mile to 2 miles across that had been orbiting this way out in the frozen tundra of beyond Neptune 10 times further, maybe 20 billion miles away. And then all of a sudden it comes in. Some comets, it's the only time they'll come in to our inner solar system because they'll be flung out or gobbled up by the sun. But you see the white coma in the middle there. That's all the action going on, the rocky part of the comet, and then everything else is reflected. It's like throwing a bunch of glitter up in the air with a spotlight or something. You get that glitter, okay, and momentarily on there. So, and the star lines here, that means that this was a long exposure where the stars trailed for 1 minute, 2 minutes, whatever was the setting on there. So, all right, any questions about comets? I'm going to answer some more of your questions here. Pull together something that I wanted to try to do. I'm going to kind of demonstrate what I wanted to do here, and by showing you here that what I would do over the years is, and I'm going to have Marty, is I'd get a bucket, all right, put it on a table, and like I said, I forgot my regular kit, but we add things to this bucket that are part of a comet, and thank you, Marty, part of the comet are things that are on the Earth, all right? So I'm going to talk about this old school with a paper old flip chart here, all right? Those of you under 40 years old, maybe under 30, don't know what a flip chart is. And we're just going to embellish it just like this it is. I would walk in with my radioactive critical space item, handle with care. All right. And inside of here, I would have dry ice. And I'm sorry I couldn't do that today. It breaks my heart. No dry ice available anywhere here in Florida. Uh, maybe Marty, people used it for the hurricane. That's what probably happened. Because usually the Publix always has a big thing there with a penguin on it. You guys know what I'm talking about. And now I just probably realize why we don't have dry ice, because people used it to keep their food there during the hurricane. So didn't think that through. Anyway, I'd make a big deal about this. I've talked to a lot of grade schools, junior highs and high schools, all kinds of astronomy groups about this. So let's just get down to Halley's Comet in 2062. That's 42 years from now, Marty. Let's see. Man, I'm going to be pushing it, man.
Which different color pen?
Yeah, well, good. I'll be well over 100 years old when it comes back. So let's look at what comets are. Where did the water come from in the solar system? Okay. And it definitely came from comets. All right. Out just a little bit. That's good, Marty. It definitely came from comets. We don't understand exactly where all that water came from comets. The Oort cloud of comets. All right. The Oort cloud is the blue fluffy area here. All right. Pluto, the Kuiper belt. We hadn't talked about the Kuiper belt. Is 4 to 10 billion miles from the sun. Pluto is 4 billion miles from the sun. It is one of the inner objects in the Kuiper belt. What's the Kuiper belt? The Kuiper belt is larger frozen items out there, okay? The Kuiper belt's larger frozen items. Here, if I go back this way, there's larger frozen items. And, there you go, buddy. A passing star down here could possibly trigger a bombardment of comets into the inner solar system, all right? And all this star has to be is like 1 to 3 light years away. The nearest star system is 4 light years away, Alpha Centauri, all right? Would that affect this Oort cloud? There's no pictures of the Oort cloud. It is still a theory, yet it's a solid theory that there is this big sphere of frozen debris left over from the creation of the solar system. The stuff in the Kuiper belt is rockier items, all right, like Pluto. Pluto's one of the largest items in the Kuiper belt at a little over 1,200 miles across. There's 3 other rocky bodies in the Kuiper belt that are larger than Pluto. That's why we renamed Pluto a dwarf planet. We were going to have to add 6 or 7 planets to the solar system or create this class of dwarf planets. So the Kuiper belts are like comets on steroids. We think that closer to the sun, Pluto would have a tail coming off of it, quite possibly. Now, so this tremendous, you're talking 100 billion miles away. And yes, the Voyager spacecraft have not reached there yet. They're only about 12 billion light years away. Miles away, not light years. All right, so Pluto is barely visible on this scale here. So a passing star could trigger all these comets coming in and bombarding the inner solar system and hitting the Earth. Now, the Tunguska meteor incident that leveled 1 million miles of forest in 1903 or 4, something like that, up in Siberia. They think that was caused by a comet that it didn't hit the Earth, but the impact laid stuff out. Now, Marty, you've heard about in our epoch of 4.5 billion years on the Earth that there are periodic extinctions that they went on. They know that the dinosaurs went extinct 65 million years ago. 200 million years before that, I think, was an extinction period. There's 4 or 5 periods where the Earth has been wiped out. And I don't know a whole lot about that, just enough to be dangerous and be fascinated about it when I see it on a documentary on TV. But does this mean that maybe a passing star triggered this bombardment of debris? And I'm talking hundreds of billions of comets, not the one like the Shinshin we saw. Imagine our sky filled with comets like that because of this debris pulled in here. Maybe that caused the extinctions. All right. What are comets? Comets are a nucleus of rock in ice, porous, loosely held together by loose gravity. A gaseous tail comes out of it when it gets close to the sun, and a debris tail comes off. The nucleus is surrounded with a haze of material being thrown off of it called the coma. That comet I showed you earlier, we've actually got a movie of combining photographs together of the spacecraft that went to it. Rosetta is the name of the spacecraft I just thought of, and it actually put a lander on there that got in a crevice. But you see, like snow falling on this. It's like snow falling on it inside this coma. All right, the comet is blown away from the sun as it comes in from the outer solar system, and it does a quick U-turn, and as it comes around, the comet is ahead of itself. Doesn't make sense logically, but that's physics, makes perfect sense about that. So what are comets made of? They're water. So I'd pour some water in here, okay? They're rock, and I'd pour some rocks into here. Carbon, basic thing of life. Throw some charcoal in there, some carbon, all right? Ammonia. It's a big ingredient in the outer solar system for some reason. So I'd take some, ooh, look at that. That's cool. Take some ammonia and squirt it in there, all right? And a lot of water, but there's dry ice in there. It's foaming up. People are like oohing and on. They better get some dry ice for Halloween, by the way. So ammonia is a big deal. Amino acids, the building blocks of life, are part of a comet, all right? And minerals, lots of minerals. We found all kinds of things on the chart, the minerals, copper, different, all kinds of things on there. Probably find gold on there. So that is what we find in a comet, are the building blocks of life, but it is like 90% water or frozen water, all right? And then this water, like I said, heats up and spews out, and probably in like steam or something. It sublimates. That is what I love showing kids, Marty, is dry ice. Is you take dry ice, and I take it, and you breathe in. We're breathing in nitrogen, 70% nitrogen and 29% oxygen. We breathe out. We're breathing out carbon dioxide. If I could take that breath of carbon dioxide, bottle it, and make it 110 degrees below zero, I have dry ice, all right? Because every substance has three states of matter: a solid, a gas, and a liquid. But what so water is liquid water, and I always stump people on this. Liquid water is liquid. What is H2O in the solid form? All right, that's ice, right? What's H2O in the gas form, Marty? Steam. He got it. All right. He still remembers Grandma's steam buggy she had there up there in Long Island. But steam. So that's the three parts of air, of water, I mean. But dry ice, frozen, goes, I throw it on the ground and on a floor, and the kids are like, I'm going to have to clean up this mess. And then all of a sudden there's nothing there. The dry ice goes from white. You can see it kind of smoke coming off of it, and it's gone. That's called sublimation. And that is what these comets are doing. They're sublimating. They're going from a solid state to a gas state immediately by the energies imparted on it by the sun. So we mix all that stuff up, and of course, I'm very dramatic about it and have a good time doing it. And then, voila, we produce a comet. Now here, voila, there it is. Let me go back there. There you go, buddy. Thank you. Now I have a comet in my hand there, but I'm going to show you when. Yes, I have a whole uh, persona that I do on this Cosmic Q with the hat and the lab coat. But here you see me cooking it up recently at an event with a bunch of kids during the summer, and you see the it's I have it in the bag, and as I compress it in that bag, the steam comes out, but it's the sublimating gas of the dry ice, and I really have to put pressure on it inside that. Very, very hard. And everything is melting together. The rock, the carbon, the minerals, the ammonia's in there. And it's all getting together. And then I pull it out, and minerals give it a color. That's why I use different colored sand. And if it was hotter in there, you'd see it steaming off. It's lumpy. Looks like a comet that we've been seeing pictures of on there. So sorry I couldn't do that for you live. We'll do it another time. But yeah, no dry ice in Brevard County on there. So hope that you've enjoyed that. If you've got any last minute questions, Steve Jokums, thank you for watching. Yeah, go ahead, Marty.
I got a comment from Cliff Watson. They have seen a tail from Pluto.
They have seen a tail on Pluto. Yes, Cliff Watson. I wasn't going to get into that. How can they see the tail on Pluto? It's through other scientific investigations with the Webb telescope. They also see a tail on Mercury. A sodium tail of sodium ions being ripped off of Mercury. There's people that'll buy a sodium filter and you can see that. So thank you. Good that you're watching and awake, Cliff Watson, down there in Pomona, Australia. In the middle, getting into springtime there. Gary Gerald's watching, Bill Whiting, Mitch Rothman, Dave Stange, Doug Forrest, John Borelli, my daughter Jessie, and that means McKinley and Macy are watching. Hi, McKinley. Can't wait. Grandpa can't wait to make you a comet someday. Robert Law is up in Dundee, Scotland. Tom Celentano, Carlton Bailey, Dean Babcock, and Steve Jokums. And I'm sure they all wish us well with the changes made here at the American Space Museum. Once again, Gabriel Rothblatt's going to be our executive director and take care of the financial development and grant processing. And I'm going to be the museum director, handling the day-to-day with a great team of people that includes Nick Enix, Anita Truex, Connie McDaniel, Bruce Jacobs, Dan McCune, and Marty, and also many volunteers here and docents like Eric Baker, who did a program Friday on Goddard's Day. We enjoyed that. John Smith, another great docent, Steve Izzo, and don't want to leave Barry Smith out and his wife Barbara. So our family's going to grow. We're going to keep doing the things we've been doing, and it's all because of your support out there. So now there's another close-up of it there, even closer up there of that comet. And I have a glove on. Yes, it's very cold. I touch it. We tell kids not to touch it. And I need to make a picture of this. Very interesting, folks. I put this in a glass container. Let's say I put it in a glass meatloaf container or something like that, casserole container. The next day when I come to see it and it melts, you have a layer of scum on the top, kind of a layer of dirty water in between. You have sediment on the bottom and a clean layer. You have an ecology ecosphere there after this thing melts. It's so obvious that this is how our world and others were seeded with a lot of the elements of life today. So hope that you enjoyed that. We're going out with another rare comet. Again, part of the comet, Marty, split off, all right, and was gone and would dissipate just like smoke in thin air, but it's full of pebbles and rocks and stuff that we go through. This is what the Perseid meteor shower is part of a comet. The meteor shower going on now, the Orionids, is part of the Halley's Comet. Look at how interesting this is, how this is splitting off in dynamics. Look at the coma, has a bluish area ahead of it, all right, of gases. We don't quite understand all this, so tell your young people out there, cometary astronomy is a growing field just like astrobiology. So, all right, enough from me. Let's thank you all for your nice thoughts and everything. Marty, space trivia question of the day.
Okay, again, the question was Kathy Thornton tested the DAC during long duration high altitude flights. What is the DAC? Well, Steve Holcomb answered. Steve, I'll give you partial credit. You gave me what the acronym stands for, which is Disposable Absorption Containment Trunk. Well, what that is a diaper.
There you go.
And that's part of the answer we were looking for. So, partial credit, Steve.
All right, a diaper. All right, a DAC, the diaper. And I didn't see Kathy lined up for the next few months out there, but she'll be out there probably in the spring. You will have to cajole her about that. But we're trying to get her at Shuttlefest, so as a EVA astronaut on the Hubble. And you'll be hearing more about Shuttlefest next week. We're excited about the administrative decisions made here so that we're empowered to do the things that we have in place, and that includes Shuttlefest and a week from Saturday, a memorabilia show at Beachside Hotel. So tomorrow we're going to catch up on space news. We're going to have the undocking tomorrow morning of the Crew 8, I believe, about 9 o'clock. Hopefully that goes on, and see what time they're coming home. And Mikey Haddad had to postpone his monthly visit because of family obligations, but we're going to have that Thursday. We're going to try to have a astronaut interview we've been putting on hold, and Friday we'll have a very special program. I promise you will not want to miss on Friday. So the usual type of Stay Curious activities. Don't have too many guests this week, but we're getting lined up for next month. So thank you all for watching. I appreciate all of you supporting our wonderful nonprofit, the American Space Museum, and our foundation, the U.S. Space Walk of Fame. And until next time, I'm Mark Marquette saying, I can't wait to see you in our museum to bridge the space between us.